What is going on, ladies and gentlemen? In this video I'll be going over what is serverless architecture. It is a phrase or word that is used a lot nowadays, especially since the expansion of the cloud. But I just want to go over some concepts and what exactly is serverless architecture and how you can implement that and why it's so great to use currently. So hope you guys enjoyed the video. Like always, the article for this video to my blog is in the description. Enjoy. So what is serverless architecture? Well, a serverless architecture is a way to build and run applications and services without having to manage infrastructure yourself. Back in the day, a company would have to buy servers, build a service center to store clients' information. But now with cloud providers like AWS, GCP, and Azure, they don't have to do that anymore. There's still servers being used in serverless, but it is now provisioned and ran by AWS, GCP, and Azure, by your cloud providers, right? And now that all that work is being abstracted away from the application developer, and now they can just focus on code and deployments. So an engineer can write and deploy code, while a cloud provider provisions servers to run their applications, databases, and store systems at any scale. And this is why providers like AWS, Azure, and GCP are making the big bucks right now, right? This is why it's so vital, because we can just focus on delivering the product. And like this photo on the left shows, they handle the databases, they handle provisioning the function, like the functions that we're going to talk about later in this video. They handle the APIs, right? All we got to do is code them and deploy them to the cloud provider. So that is serverless architecture. It's just leveraging these providers to handle all of these different resources for us. So how does serverless architecture work? We talked about it a little bit. Well, this little diagram shows like a client sending a request to either it can be a function, which, like I said, we're going to talk about later in the video, an API that we have stored in the cloud provider. But let's bring it back a little bit, right? So a server allows a user to communicate with an application and access its business logic. That's the whole premise of it, right? But managing a server takes a considerable amount of time and resources, right? Teams have to maintain the infrastructure, take care of the software and security updates, and create backups in case of failure. That's a lot of work, and that's a lot of money, and that's a lot of people that you'll need for that. So by using serverless architecture, engineers can reduce the responsibility and let the third-party provider handle all of that, enabling to just focus on code. So that's what it shows right here, right? It shows that a client can just send a request to our wherever we're storing our infrastructure, right, our resources, which is a cloud provider in this case. AWS, GCP, and Azure are the three popular ones. And whatever logic or business logic that we have that is being stored and that was deployed to the cloud provider would then send a response, right? Just like how it normally would be done if we were to do, if we were to store it or deploy it on our own servers. And like I said, the function, right? So a popular serverless architecture tool is a function as a service, FAAS for short, right? And that's a little function box that I have in this cloud provider box that I have on the screen, right? So essentially what this function as a service does is it allows developers to write their application code as a set of discrete functions. So each function will perform a task when triggered by events such as uploading to a database or even a HTTP request. So after testing, engineers can then deploy these functions along with the triggers to a cloud provider, and when a function is invoked, the cloud provider will either execute the function of a running server, right? Or if there's no server currently running, it spins up a new server to execute the function, right? So that's a powerful tool that's being used a lot in serverless architecture. And this is all being extracted away from the view of engineers who can just focus on writing and deploying the logic behind that code that encapsulates or that that the function entails, right? So a good example of this is the video that I made in regards to Lambda functions and S3 buckets, right? So in that video, essentially what I did was once you upload to the S3 bucket, there's a function that essentially logs the information, right? And that was a pretty important video because it gives you a whole flow of different permissions that you can use and everything being done through AWS and also the server was through Node, but that can be uploaded onto AWS as well, and all that logic can be done, completely in AWS. So AWS created a service in 2014 called AWS Lambda, like I just talked about. It essentially allows you to upload these functions onto AWS, and it runs some logic that you code up based on specific triggers. And it became the most popular service for creating cloud functions. And I made a video about that as well as an article. I'll leave that somewhere on the screen and in the description. But in that video, I go over more about what a Lambda function is. I don't want this video to be too long, so if you're more curious on what a Lambda function is and how to create one, I'll leave a video somewhere on the screen. So here are some concepts that I think you should know about, serverless architecture, some words that are used very often when discussing serverless architecture. So the first one is duration. That just means the time it takes for a serverless service to execute. So it's really just time. Cold start, which is just the latency that occurs when a function is triggered from the first time or after a period of inactivity. So sometimes when we use these functions that are being stored in AWS, or whether there's a function that were created through Azure, that initial call may take a little longer because it takes a while to spin up, right? So that's why they call it a cold start, kind of like an engine, right? If you ever had a car in winter, sometimes it takes a little while to heat up, right, to start that engine. So that's the cold start when it comes to different services in the cloud, right? That first initial call is usually slower than the future calls. So that's why I believe cold start is a pretty important thing to understand. Then there is concurrency. It just means that multiple computations that happen at the same time. So if it's handling multiple requests that are coming into the system, concurrency is something that's very, very important, and it's important for your service to be able to handle concurrency, because you may have somebody in Idaho, right, and somebody in New York trying to make a call to your system, and your system should be able to handle requests that are happening concurrently, happening at the same time. Then there's timeout, right? Timeout is just the amount of time that a cloud provider allows a function to run before terminating, or anything to happen before terminating. It could even be your API, right? So it's a period of time that, after receiving a request, that you have to handle that request. So it can be 5 seconds, it could be 10 seconds. It really is just based on business needs. Sometimes a request may take longer to process, so you may need a longer timeout. But understanding this and knowing that after a certain period of time, that request will be canceled because it took too long, is essentially what a timeout is, right? So most providers set a default timeout and a maximum timeout. So usually this can be increased or decreased, like I said, based on business needs. So invocation just means to invoke something, right? So in this case, let's use a function as an example. We talked about Lambda functions so many times, but say for instance, we have a block of code that we want to run when we upload something to S3 or into our AWS database or Azure database, and we want to invoke something, right? Invocation is simply like invoking, a piece of code or invoking a request, right? So invocation is a very important term to understand, or a very important concept to understand, because it's a word that is used very often. Then there's event driven, all right? So a program written to respond to an action generated by a user or a system. And we talked about that as well. So say for instance, you have a individual that uploads to AWS S3. That's an event, and we can listen to those type of events, and that can trigger something else to be done. So in the video that I made with Lambda and S3, that can trigger a log, right? Or that can trigger a function to log the event that just occurred, just to have some vision on what occurred. And say for instance, you're a bank and you want to whenever you receive a transaction, you want to be able to know that transaction even occurred. It's good to have something that logs that information. So that's an example of event driven. So it can be anything, right? It can be inserting into a table, it could be inserting into a bucket, it could be listening for specific HTTP requests. Each event would trigger an action. So then there's stateless, right? So stateless is when outcomes are not influenced by previous events. So a stateless system sends a request to the server and relays the response or state back without storing any information. So a good example is when you log into a website or log into, you could pick an app that you like, and usually if they're using JWT tokens, right, when you log in and you're authenticated, you receive a token. Usually, the app or the website doesn't store the JWT token internally. So it is considered stateless. But whenever you actually authenticate properly, you receive the JWT token, or the client receives the token, and that's being stored somewhere. And whenever a call is being made, that token has to be sent to the server, so that can be used to authorize if the user is proper. But the server doesn't have that token being stored internally. It's the client that received the token, and that's what makes it stateless, right? The server doesn't store anything, but it receives, or it sends a response back to the client that can be used for future requests. So understanding that concept is pretty important. Then there's function as a service. We talked about it a lot. Lambda functions are probably the most popular one, and it's a cloud computing service that allows customers to execute code in response to events without managing any complex infrastructure, typically associated with building and launching microservice applications. So instead of having to build whole applications to deal with specific events, we can now create functions that will run a block of code whenever a specific event happens. So this is perfect. It goes hand in hand with event driven, which is number 6. But usually, you have a function that runs a block of code whenever a specific event occurs. So whether that's inserting it to a database, whether that's, maybe that you're updating something, right? Or maybe you send the HTTP request. This is something that can trigger a function as a service. And Lambda is a great example of that for AWS. So now let's talk about the pros and cons of serverless architecture. It is going to have to be a decision that you have to make, whether a company or whether you're an individual doing hobbies, right? You have to know the pros and cons and whether you want to make that push to using serverless architecture. Well, let's talk about the pros. I like staying positive first before going negative, right? So the first one is serverless computing can increase developer productivity and reduce operational costs, right? Because like I said before, a lot of companies will have to build their own server centers, right, to handle all that information, to handle all the client information, and that could be very costly. I know it could be costly, especially if the amount of your clients increase over time, and now you have to create a whole another server center, or maybe you're not even using the servers to its fullest capacity, right? So you spend more money than you should have because you don't have as many clients, and maybe you didn't increase to cover the cost of the server that you built. So it can be a very expensive process. So using the serverless architecture, you provision servers based on you could provision servers based on what you are using and your needs. So by offloading that work of routine tasks of provisioning and managing servers, and developers having to do security updates and stuff like that, this gives developers more time to focus on actually coding and doing actual development. So that's a pro. The second thing is, like I said, operational costs are reduced in serverless model because you can pay for the compute time that you actually use, right? Because like I said, when you're creating these server centers back in the day, you're making guess that you're going to use a certain amount of data, or you're gonna have to store a certain amount of data, and you're gonna need a certain amount of computation power, and you may get to that threshold, or you may be well below that threshold, and that can be a cost, right? You can either lose money, or you may have to spend even more money to handle the increase of clients that you have. So with the serverless model, right, you can now pay for the cloud-based compute time that you're actually using, and if you need more, you can just spend a little bit more, and if you need less, you can pay less because you're using less. So operational costs can be reduced, and it can be more efficient than having to do everything yourself. And then we're going back to the functions, right? So function instances are automatically created or removed in response to traffic variations, right? So within the boundaries of the concurrency limits. So say for instance you have, and it's not only for functions, it can be databases, it can be anything really. And I talked about that during my load balancer video, where I talked about how there's softwares that can check whether you're using or whether the traffic is too much or too little, right? If traffic is too much, your applications will scale up. If your traffic is less than usual, then it will scale down. So you're really only using instances and resources based on your traffic needs. And to me, that's a pro because AWS already has that built in. Yeah, you can configure it to based on what you need and the maximum amount of servers or databases or functions that you want to scale up to or scale down to. But the fact that you don't have to code that yourself, it's already ingrained inside of AWS, Azure, and GCP, that's a pro. And it can end up saving you money. Everything is usually about money, but there's so many things that you can adjust internally that makes serverless architecture great. All right, so the first con is not being able to run your own server or controlling your own server-side logic can be an issue for some users. Just the nature of serverless architecture is the fact that usually, like I said, AWS, GCP, Azure, companies like that, cloud providers like that, they store your information on their servers, right? They control it, they handle it. Well, they don't control it, but they operate it essentially, right? You can change it based on what your needs, but a lot of these servers are being shared by other applications as well, and that can be an issue for security reasons, especially like things like governments or even for banking. Like when I used to work in banking, you weren't allowed to, there are ways that you had to store information compared to just like regular information, right? So say for instance you were based in India doesn't allow their client information to be stored abroad. It has to be within India, right? And there are ways that you have to configure it, right? And it kind of makes it difficult when you need to grab information regarding that client, because there's a certain way that information is being stored. And when you're using serverless architecture, it can be difficult to handle those specific type of requirements because of that. I know AWS have a way of allowing users to rent a whole server rack just for them, but that's just something that you have to do a lot of research in and have the proper engineers to handle that. I know that was an issue at a previous institution that I was working at when it comes to handling information. So I would say that's a con. The second one is cold starts are common in serverless environments. So it may add a couple of seconds of latency due to the nature of serverless architecture. So that initial execution will usually take a little bit longer than other invocations of resources in the cloud. So things like functions may take a longer period of time on that first call compared to the other ones, and after a couple hours that may be the same issue. So maybe you call a function a couple times for an hour, and then you come back the next day, you got to call again. It's gonna be slower on that first invocation, but that there are resolutions to that, and I talked about that in my Lambda video. Like I said, I'll leave a link on the screen somewhere to that video, and you can go over that. But there are solutions to it, but sometimes there aren't. So, and sometimes you have to pay for those solutions as well, so that can be an issue. And the last thing is that it's normal to want to use a single cloud provider for all cloud services, because everything that it has to offer, it keeps it clean and keeps it efficient instead of having to use multiple vendors. But it kind of causes you to be reliant on that one vendor, right? It makes it difficult sometimes that you're working with AWS, and maybe Azure released something that AWS doesn't have yet, and now you have to, I guess, try to find a way for those two services to interact. I know when cloud providers I know when the cloud became more popular initially, it was more difficult. But I know right now, or currently, Azure and AWS and all these big companies are trying to make it easier for the interaction between companies to happen because of the issues that people were having. But I would say, in cases where using one vendor is not an option, like there's services that another vendor has, or maybe the cost is better on another vendor for a specific service, trying to get them to interact can be a bit difficult, and that's something that you have to think about when you're making that decision of going serverless. Is like, which vendor has the best services and best costs and best resources for me, right? Because it may be a challenge in the future to have them interact with each other. And also, you have to have engineers that have an understanding of the ecosystem of not just AWS but Azure as well. Both of them have different certifications, both of them have different UIs, both of them have different ways of coding. Like even Azure has like a thing called Bicep, right? It's a way that you can code provisioning resources, right? But that's different than how AWS would do it. So it's things like that, right? So now you have to pay another engineer to handle Azure, but then have another engineer to handle AWS. So it's things like that that can make make it a con. So these are the pros and cons, and that's what you have to look into when making a decision on using a serverless architecture. And last but not least, I want to give some examples of some serverless architecture use cases, right? So we talked about trigger-based tasks, right? And any user activity that triggers an event or a series of events is a good candidate for serverless architecture. So like I said before, if you want to listen for events like maybe you have a Kafka pipeline, right? That whenever an event is placed on in the pipeline, you want to trigger a function to log that event that was put into the pipeline, or maybe you want to consume that event and do something with the function, the Lambda function, right? So these are trigger-based tasks that can be done, and usually going the serverless architecture way or approach is the best way of handling those type of situations. Then there's building RESTful APIs. So there's tools like AWS API Gateway and AWS Lambda that allows for the creations of serverless REST APIs. So the request can be redirected from AWS API Gateway, and it can be ran using Lambda functions, created for different types of events like login, registration, and these functions can connect to, database instances, with things like AWS RDS, or if you want to use, NoSQL, you can use Dynamo, and now you have a fully functional backend, right? So you're handling requests through HTTP, you're, triggering a Lambda function, and that can store information to, your databases that you have, all on the cloud. And last but not least, we got the CI/CD flow, and it's something that I use a lot, right? So it's serverless architectures can automate many of the stages in your CI/CD pipeline. So I actually use this very recently a lot in Azure. You can provision, CI/CD flows using, just a simple YAML file. So you can have a GitHub where you store information, your code, and you can have specific branches that you have for deployment. So if you were to push to a branch like develop, or maybe you have a branch called main or production, and you push to that can trigger a whole pipeline. And I was able to make a YAML that there's certain conditions that has to pass, but whenever a person pushes to a branch, it takes the application and it deploys it into different stages. It's going to ask or send emails to engineers for approvals, just to make sure that the deployment is actually approved by a certain amount of engineers. And I even used a CI/CD flow to execute metadata, so I can take information from one backend and provision it to another backend. And that probably sounds like a whole bunch of hoopla, but I'm just saying the power of serverless architecture when it comes to deploying your code is very powerful, and it can be done just using a YAML file, and it can listen to your GitHub, right? It can listen to the actions in your GitHub, and based on that, it can deploy your code, and all that can be done right back up into the cloud, right? It can deploy it using different services that Azure and AWS and GCP has to offer. So these are the use cases that I feel like serverless architecture will be great for. So if you feel like it fits the criteria of any of these descriptions, then this architecture can be for you. So hopefully you found that useful. You can go ahead and subscribe. More of this is coming. And yeah, hopefully serverless architecture is for you. Do your research. If you have any questions, leave it down in the comment section. Thank you.